Yes, hi, this is George Rakis again, and today I would like to discuss about how to do integration by completing the square. First of all, I will start with when you use this method here. So you use this method when you have to find an integral of a rational function of this form f of x over ax squared plus bx plus c, where of course this here the denominator is quadratic, and of course the f of x is of a degree less than 2, or it can be brought into this form, of course by division of polynomials. And what else you need to have in order to use this method here? You cannot just find this integral by a simple substitution, like substituting only your denominator equal with u, and you also need your a and b to be different than 0, because if a is 0, then it's not the denominator is not a quadratic. If b is equal with 0, then it becomes ax squared plus c, which is an integral that we can calculate in another way. And of course you need the discriminant to be, the discriminant of this quadratic to be less than 0, because if it's not, then that means that you can factor this here into linear factors, and then you can do this by partial fractions. So that's the one you need to use this method here by completing the square. So now let's see how we do it. So let's say we have an example. We have to find the integral of 2 over 3x squared plus 5x plus 4, of course always with respect to x. And of course you have that 3 and 5, which are your a and b, are different than 0. Your discriminant, it's 5 squared minus 4 times 3 times 4, it's 25 minus 48, that's negative 23, so that's negative. And of course if you try to solve this by substituting u equal with your denominator, it won't work. So that means that you have to use this method here of completing the square. Now, what's the theory that you need for this here? The only theory you need is these two identities. The a squared plus or minus ab plus b squared is equal with a plus minus b squared. Of course, when you have a negative here, we have a negative over here too. And that's now, we have to work, of course, on our denominator, because that's where we have to complete the square. So let's start. So you got your denominator here. So what you do, the first step is you take the 3 outside of the brackets. So what's left inside is x squared plus, forget about this 2 over 2 for a minute. What is left when you take the 3 outside here, that will be 5x over 3, of course, plus 4 over 3. Now, why I multiply and I divide by 2, that will help you to recognize what is your b, this b here. That's why I did it. So if you compare, this, the left hand side of the identity, of this identity, with what we have here, you can see that your a is your a is x. So x is here. Now this is your 2, this is your x. So what is left is this here, which is inside the red figure. So if you compare this with all these, you see that your b is 5 over 2 times 3. That's why I multiply and I divide by 2, because this is the easiest way to find your b. And so that's your b, so which is of course 5 over 6. So now, in order to complete the square, what you are missing from here, you are missing the b squared. So the b we said is 5 over 6. So you just have to add the 5 over 6 squared, and of course you have to subtract it in order to be the same with the one before, with this here. So and of course you add the 4 over 3. So now of course if you use this identity with the plus sign, you can write these three terms as, of course the 3 is here, so you can write these three terms as x plus 5 over 6 square. And of course if you do the calculations here, that will give you, this and this will give you 23 over 36. And that's it about completing the square. So now of course you go back to your integral here. So instead of this we substitute this here. So we have to find this integral here. You can take the 2/3 outside of the integral since it's a constant. And now you have to find the integral of this here, of course always with respect to x. What we do here, we do substitution. You just substitute wherever u equal with this here. So that means that du over dx, if you find the derivative of this with respect to x, you have that du over dx is equal with 1, which of course gives us that du is equal with dx. So if you go back here, and of course instead of dx you substitute du, and whatever this here you substitute u, so you have u squared plus 23 over 36. And of course, this integral here, the integral of du over u squared plus 23 over 36, it's an integral which is given, or if it's not given, you can again find it with a simple substitution. So the integral of this here, it's 6 over square root of 23 times the inverse tangent of 6 over square root of 23 u plus c, of course, since we have an indefinite integral. And finally, you have to substitute whatever u equal with this here, x plus 5 over 6, and that will give you the final answer. Of course, you do here some small calculations, and the final answer will be 4 over square root of 23 times the inverse tangent of 6 over square root of 23 times x plus 5 over 6, plus of course c. So that's how you do integration by completing the square. So thank you for taking the time to view this video, and I hope you find it useful, and bye for now.